So, in continuation of the syllabus topic discussions for the subject computer organization, wherein we have covered till now Unit 4, and the last topics which we discussed were virtual memories, memory management requirements, performance considerations. So, coming to Unit 5 deals with performing arithmetic, addition and subtraction of signed numbers, multiplication of positive numbers, Booth algorithm, followed by pipelining concepts. So, coming to the chapters from the prescribed book, Hamasher, the Unit 5 related to arithmetic is available in Chapter 2 and Chapter 6, while pipelining concepts are available in Chapter 7 and Chapter 8. The today's objective is understanding how arithmetic is performed, and that too specifically we are trying to understand unsigned multiplication with a small example. The example also will tell us about the algorithm steps. So let us take the example for unsigned multiplication. So unsigned multiplication is, here we are taking multiplication of two numbers, so which do not have a sign, a negative sign. So you can see here our example. There is one number called as 7, and there is another number called as 6, and multiplication of 7 and 6 leads to 42. So here 7 is the multiplicand, 6 is the multiplier, 42 is the product. Coming to denotations, multiplicand is denoted as M, multiplier is denoted as Q, and product is denoted as P. In the algorithm for unsigned multiplication, C and A are used. Here the assumption is that these numbers, which are our decimal numbers, are represented in binary form with the help of four digits. As in, you can see here 7, which is a multiplicand M, is represented as 0111. So this 0111 is nothing but, if you convert this binary, that will be coming to be 7. Similarly, this 6 is represented as 0110. It means in this example, for multiplication of 7 and 6, we are using 4 bits to represent these decimal numbers. So let us look at the conditions first. We have here Q. Our Q is multiplier whose value is 6. So here this is called as Q0, Q1, Q2, Q3. And we are looking at Q0 value. We are looking at Q0 value. If Q0 value is 0, if Q0 value is 0, then we are performing a right shift. If Q0 value is 0, then we are performing a right shift. If Q0 value is 1, then we are performing A is equal to A plus M. A is equal to A plus M, and then we'll be shifting to the right. Let us look at our example. This is how we are going to keep the order. First C, which will be used in the algorithm, its value is denoted as 0. Then A, which is initialized to again 0. Then we have our Q. Q is our multiplier. Q is our multiplier. Now this is the initial step. We have keep this in order, C, A and Q. Now let us look at the Q0 bit. What this Q0 bit is, it is 0. And let us look at the condition. If Q0 is 0, then we are shifting to right. We are shifting to right means this rightmost bit will vanish. this rightmost bit will vanish. So now rest of the bits will be moved to the right, and the C zero value is retained as it is. So what will happen is, as this is vanished, zero is vanished, this will vanish now. So the new value is 0 1 1 shifted to right, and this 0 brought here. Rest of the three zeros are brought here, and this 0 is brought here. This is how right shift has occurred. Now let us look at Q0 value again now. Q0 value again now. So Q0 value is 1. If Q0 is 1, what step we are performing? If Q0 is 1, then we are performing A is equal to A plus M. What is the value of A? The value of A is 0 0 0 0. What is the value of M? 0 1 1 1. So A plus M will be how much? A plus M will be 0 1 1 1. So at this stage here, this is this 0 1 1 1 is a resultant of performing A is equal to A plus M. Performing A is equal to A plus 1. Rest of the bits are brought down as it is. Once we have taken this step of performing A is equal to A plus M, then we are going to right shift. When we say we are going to right shift, this rightmost bit 1 will be vanishing. Rightmost bit 1 will be vanishing, and this 0 0 1 will be coming to the right, and this 1 of A will be brought here. So 0 1 1 will be brought here, 0 from C will be brought here, and C0 is retained as it is. So this A plus A is equal to A plus M and shift is one step. So you can see that this is step number 1, where we have just performed a shift right. Then this is step number 2, where we have performed A is equal to A plus M and then shifted. Now let us, after shifting, let us look at the rightmost bit. So what is the rightmost bit now? The rightmost bit, which is Q0, is 1 again. So if Q0 is 1, what we are going to perform? A is equal to A plus M. So let us look at the value of A. What is the value of A? 0 0 1 1. So we are going to add 0 0 1 1 to 0 1 1 1. Okay, so that will be resulting into 1 0 1 0. So this 1 0 1 0 is a resultant after adding A to M, and the latest value of A is 0011 and M is 7, which is 0111. Hope you are able to understand and connect with this. Now rest of the bits are brought as it is. After performing this A is equal to A plus M, we are going to do right shift. When we perform right shift, this rightmost one of Q0 at Q0th place will be vanishing. So this 100 will come here, the 0 part will come here, this 101 will come here, and this 0 will be brought here, and this C will be kept as it is. So this is the resultant of the next step. A is equal to A plus 1 M and shift. So till now, first step we performed was, first iteration was shift. Second iteration was A is equal to A plus M and shift. Third iteration was A is equal to A plus M and shift. Now let us look at the rightmost bit, which is Q0th bit. And the Q0th bit is 0. If Q0th bit is 0, then we are performing right shift. Then we are performing right shift. So if you are performing right shift, so the 0th value will go, this 0 value will vanish. So 0 1 0 will come to the right, this 1 will come, and this 0 1 0 will come here, this 0 will be brought here, and this 0 will be kept as it is. Now you have the resultant here as 0010 and 1010. Take this entire binary value, convert this entire binary value into decimal. So simple, but this will be how much? 0. This will be how much? 2. This will be how much? 0. This will be how much? 8. This will be how much? 0. This will be how much? 32. Then 0. Then 0. So 32 plus 8 plus 2, so that comes to 42. That comes to 42. So that's how 7 multiplied by 6 is equal to 42 is the product, and that's how we have performed using this simple algorithm of unsigned multiplication, so what are the algorithm steps? If somebody asks you, what you will say, we are going to keep this order CAQ. Q is the multiplier. Then we are going to check the Q naught value, if it is 0 or 1. If it is 0, then you are going to perform the right shift. If it is 1, then you are going to perform A is equal to A plus M, then the right shift. So let us take one more example. Now, in this example, we are taking 13 multiplied by 9, which comes to 117. 13 multiplied by 9, which comes to 117. So, what is 13? 13 is multiplicand, denoted by M. What is 9? 9 is multiplier, denoted by Q. What is 117? 117 is product, denoted by P. So the C value is as usual 0 and A value is 0000. Here again, let us remember that for representing this decimal number, we are using four binary bits. We are using four binary bits. So C is 0, A is 0000, and Q is 9. And the binary equivalent of 9 is how much? 1001. And M is 13. What is the binary equivalent of M? It is 1101. So let us do the same thing now. What condition we have to check? We have to check if it is Q0 value is 1 or 0. If Q0 value is 1, what step we are performing? A is equal to A plus M, then shift. So this step 1101, where we have written under eighth column, right? So how we got this? This is A is equal to A plus M. A is 0000 plus M is 1101. So this is coming as, and rest of the bits are kept as it is. Once we perform A is equal to A plus M, we are shifting it to right. We are shifting it to right means what? This one will vanish. Once this one vanishes, this 100 comes to the right, this one comes here, and this 110 comes here, and this 0 will be brought, and this 0 will be kept as it is. So one iteration has been finished. This iteration has actually two steps, A plus M and shift right. Let us look again at the rightmost bit. What the rightmost bit is saying? It is saying the Q naught bit value is 0. If it is 0, what we are doing? We are performing the right shift. If we are performing the right shift, this Q naught, the rightmost 0 will vanish. So this 110 will come here, this 0 will come here, this 011 will come here, and this 0 will be brought, and this 0 will be kept as it is. Again, let us look at the rightmost bit. Rightmost bit is Q0th bit. Q0th bit is 0. If it is 0, then we are performing the right shift. If we are performing the right shift, the 0 value will go. So it will be 011 at the right. This 1 will be brought here. Then this 001 will be brought here. This 0 will be brought here. This 0 is as it is. Now again, we are looking at the rightmost bit, which is the Q0th bit, whose value is 1. If it is 1, what we are going to perform? If it is 1, we are going to perform A is equal to A plus M. What is the new value of A? The new value of A is 0001. What is the value of M? 1101. So we have to perform 0001 plus 1101. So this will be resulting in 1110, and rest of the bits will be kept as it is. So once we have performed the A plus M, the next thing is we have to shift it. So if you are shifting it, this rightmost one will vanish. So this 101 will come here, this 0 will come here, this 111 will come here, this 0 will be brought here, this 0 is as it is. Now, after this, this entire binary number, has to be converted into decimal number. So this is how much? 1, this is 0, this is 4, this is 0, this is 16, this is 32, this is 64, this is 0. So we are adding 64 plus 32 plus 16 plus 4 plus 1, which is coming to 1117. So hence we performed unsigned multiplication of 13 multiplied by 9, resulting in 117. Hope you understood this very simple example.